NASA Group Achievement Award. He has published
what I did. I went over, and in US. So if we want to look back in time and know more about this universe, we'll have to look. Can go back only up to about 385,000 years after the Big Bang, because in the Big Bang, from a small point, it expanded, and it first radiation of this universe came out after about 385,000. It's called cosmic microwave background radiation. So what we are trying to find out is that how this universe was formed, how galaxies and stars are formed, and we can do that by studying this radiation, this cosmic microwave background signal. And so my first project was actually building some instrumentation to do that, to actually understand. There was a kind of instrument that we are building called BICEP. So BICEP instrument was trying to look at the cosmic micro background signal, and this is an extremely difficult signal to detect because it's so tiny. And so I actually became a part of that and started building some antenna design and many other things for that instrument. That was one of the things. And the other thing I did was another instrument called Herschel mission. That is an astrophysics mission. It was going out to outer space and looking at stars and galaxies. All of us want to know how, from where we all came from, how stars and galaxies are formed, right? So one of the things that NASA does, a lot of people ask, what is the main goal of NASA? What do we do exactly, right? So one of our main goal for everyone's goal is to find out, are we alone in this universe? Is there life anywhere else outside our Earth, right? And in that, you read a lot of stories and conspiracy theories that there are aliens and all. So let me tell you first that we have not seen life anywhere else other than Earth. So if you hear about those aliens and all, there is no proof really. So if you can show me and that you actually really found some aliens, oh, that's great. We'll be the first one to go and tell you, oh, yes, excellent. But we have not found life anywhere else outside our own Earth. So one of the things that we are trying to do from NASA is actually building instrument and trying to find out, is there life outside our own Earth, our own planet? And if you ask me this question, that is there really life? What do I think? My answer to that will be that I think there is a possibility that there life exists outside our own planet. Why do I say that? Right? That question is, why do I say that? If you look in the skies, there in our own galaxy, we all know that we live in Milky Way galaxy, right?
Yes.
So in the Milky Way galaxy, we have about 100 billion stars. 100 billion stars. And then we have about 100 billion galaxies in our universe. That is huge, right?
Yes.
So that means 10 to the power 22 to 10 to the power 24 number of stars in our universe.
Yes.
And we are finding that each of these stars, many of these stars, they have a lot of planets. And we are finding that our many of these stars outside, they have planets like our own our own sun and the planets that we have, solar system. And in majority of the cases, number of planets around those stars are more than one, which means that we are finding that there are thousands of planets out there other than our own planet. So what is the probability that in one of these stars, one of those 10 to the power 24 stars, there is one planet which is very similar to our own planet, and the conditions are such that life can exist. So probability is very high, and that's what we are actually building instruments to look into those, that is there life there.
Okay. So I have seen your research papers, some of your research papers. Sir, 350 research papers in your entire career. So that is an amazing thing, sir. Actually, writing having a
I
350.
missed that question. Actually, your sound cut off. Can you repeat the question, please?
Sir, actually, I have seen your papers, research articles. So that
Mm-hmm.
350 research articles you have done in your entire life career. So how was that motivates that to do such type of research activities?
Yes, it's that's very good question, and then many of you are actually are students and
Yes.
you are faculties, starting your career, and so it's very important that when in our education system back home in India, one of the things that we do not pay much attention
Mhm.
is the writing skills. We always think about, oh yes, you have to be good in physics, you have to go good in mathematics, you have to be good in chemistry and all those stuff. But it's so important. I realized when I started doing my research work that it's so important to write well. So we are not trained to write very well. So it is a struggle when you are actually, my screen froze. Just give me a second.
Yes,
So
sir.
when you are doing doing your research, it's very important that you write well, you speak about your work well. So I have I have a lot of postdoctoral fellows. I have great colleagues. So that's why I am able to do a lot of new work, and I always like to think about things in a different way, in the sense that how do you solve the problem, right? We are facing problem in every single day, and how do you solve it? And then in the process you come up with new ideas, and when you do, it's important that you actually write it up and let others know, so that they do not have to redo won't have to go through the same thing again, so that they can know about it. And that's how I'm able to write those many papers. But again, it's actually a collective work. It's not my own work only.
Yes, sir.
It's a lot of people are involved.
Okay, sir. Okay. So, sir, our PPT is ready to be shared. Shall I share that right now?
Sure. Sure.
Yes, sir.
We can go through that. I
Yes,
was
sir. We
talking some
can.
of these
Yes, sir.
things
Sure.
anyway. So
Sure, sir. So, kindly have a look whether you can see the screen or not, sir.
sure.
So, when the screen is visible, please
Yes,
let me know.
Scott, can you make it full screen
Yes, sir. I
there?
can make.
Like
I can
click
make.
at the bottom,
Yes, sir.
the slideshow mode. Okay, so, yes, I can see the screen. So this is what I wanted to talk to you about. NASA technologies to find life beyond Earth and answers to other science questions. If you go to the next slide.
Yes, sir. 1 minute, sir.
So I want to acknowledge, as I said, that you do not work in a vacuum. There are a lot of people that actually you work with, and nowadays, the problems are very complex. So you cannot really solve most of them by yourself. So you need to have a team. I want to acknowledge my team. The team that I work with is called Submillimeter Wave Advanced Technology. So there are a lot of people. There are 24 people, and if you look at their faces, you will realize that they're from all over the world. So that's one of the things that makes NASA great, is that we have people, the best people from all over the world. So from every country you can name of, there is one person here, and that is the greatness of this place. That just I get amazed. My colleagues, the people who are working with me, they're so smart. It is very humbling. If we go to the next slide.
Yes, sir.
So I want to also talk about that NASA. A lot of people know about NASA. So NASA has a lot of different centers and laboratories. So our headquarters is in Washington D.C. That is in the East Coast, and I am on the West Coast. That's in Pasadena, California. You can see there the JPL, Jet Propulsion Lab, is one of the largest NASA laboratories where we do a lot of robotic missions. If you hear about going to Mars and all this that happens in our lab. We have about 6,000 people. It's a large lab, and people of diverse background. There are a lot of engineers, there are all kinds of engineers, we have a lot of scientists. physicists, chemists, biologists. We have all kinds of people, and so that's why it's very important, that have a diverse group of people with diverse background. That's how we are able to do things, a lot of good stuff. So go to the next slide.
Yes, sir.
So I was telling you that that Big Bang and us, that we build, scientists so far, the current theory is that the universe started with the Big Bang, and the current age of the universe is about 13.85 billion years. And if you look at about 400,000, 385,000 years after the Big Bang, the first radiation came out. So if you are actually trying to go back in time and trying to learn how all these things happen, from where we came from, how the stars are formed, how the galaxies are formed, how the planets are formed. You can go back in time and try to understand, and you can go back all the way up to about 385,000 years. And so that's when the first light came out. There's a very nice story, because two scientists in AT&T Bell Labs, they were doing some experiment, communication experiment. We all do communication experiments, right? We all know about it. So they were doing some communication experiments, and then when they were looking at their data, they found that wherever they look, there was some little bit of excess signal. Little bit, not too much. If you know that signal can be represented in temperature, it's called KTB. K is the Boltzmann constant, B is the bandwidth, T is the temperature, is that's equal to power. So they were finding 3 Kelvin, very tiny amount of signal, excess to what they expected, and they didn't know what was happening. So in our lab, a lot of us do experiments, right? And when we do experiments and then we cannot understand something, what do? We say, oh, it must be experimental error, right? And then we do an error bar. So they thought that maybe there's something more to it. So what they did is they started looking into that, and then they realized they were looking at the first light of this universe. And then they published this paper, and then they went on to win the Nobel Prize in physics. And I know Bob Wilson personally, and I'm really lucky in that way. So that's how the Big Bang, these CMB, cosmic micro background signals, were detected. So I always tell students and others that when next time, when you are doing some experiment in your lab and you cannot explain some signal or some measurement, don't think that that is experimental error. You might win the Nobel Prize one, who knows. So the next slide, please.
Yes, sir. Yes, sir.
So if we are, as I was saying, that if we actually look around, we know that our own galaxy, Milky Way galaxy, have 100 billion stars, and then we have about 100 billion galaxies. So there are lots of stars out there, and we are finding increasingly that most of these stars have not one, multiple planets. So we are trying to find out, is any one of the planets has the conditions good enough, or in a way that life can sustain. And we call those planets in the Goldilocks zone. That the reason is that habitable zone. That because that they have to be, the temperature on the surface has to be such that the water can exist in liquid form. Only then we believe that there could be life. So we are actually looking for those kind of planets where they are in the habitable zone. And if you look back in our own solar system, that there is a question asked that why do we go back to Mars very often? The reason is that in the early history of Mars, it resembled very much like our own Earth. So we can learn a lot of things. How our Earth was established and how life came about, and also learn looking at Mars as well. So that's why there is a lot of interest in going back to Mars. You all know, if you go to the next slide.
Yes, sir.
We know that okay, I want to show this picture. If you look at this picture, And if I tell you that this is actually from my hometown Calcutta during rainy season, one of the roads in Calcutta, you might say, oh yeah, that's possible. No, actually, I love Calcutta, but that's not the point I'm trying to make. But this is actually not from Earth. This picture is from Mars. So what you are seeing here, that in many ways, Mars looks so much like Earth, and you get this kind of terrain if you look very closely. You realize that you get this kind of terrain only when there is flowing water, as if water is flowing, right? So if you go to Mars today, we don't see flowing water. The question becomes that what happened? Where did that water go? And can it happen to our own planet again? So we are actually trying to understand those things. And in that process, we will be, and to do that, you need to build instruments. You need to build, do a lot of mechanical engineering, electrical engineering, all kinds of engineering and science. So that's what we are doing. So, is it, can I go to the next slide, please?
Yes, sir. Yes, sir.
So again, we are doing a lot of Mars exploration. If you look at that, we started with Pathfinder, a small one. These are our rovers. And then we launched Spirit and Opportunity in 2003. The Curiosity rover was launched in 2011. Now we are going to launch one more, Mars 2020 in a couple of months. So it will be very, very exciting to do that. There are a lot of new things we are doing. There will be helicopter on that as well.
Yes.
So if you go to the next slide.
Yes.
So this is Mars 2020. This is some drawing of that. There will be a lot of different kinds of instruments on Mars 2020. And in this picture, you don't see the helicopter. So we have already mounted the helicopter for our spacecraft for this rover. So it has been shipped now at Kennedy Space Center, from where it will be launched. So the launch will be in July. So this is very, very exciting. We are all waiting to see and hope that everything goes well. Because landing on Mars is not easy. You all know that we tried in India, we tried recently, but we were not successful. Not because we are not good enough. It's because it's so difficult to do such things. It's really not easy thing to land something on Mars. So go to the next slide.
Yes.
So I want to show you this picture, and this is very important, because what you are seeing here is a picture taken by Mars rover Curiosity, and what you see here, that arc, that arrow, and there is a dress more. So this was the first time our planet Earth was pictured from the surface of another planet. So this was taken from the surface of Mars. And if you expand, you can see the Earth as well as the Moon. So this is a very iconic picture. And I want to show this picture to everyone to tell about one thing, that sometimes we all feel that we are great, we know everything and all. So next time you feel that way, that all of us are great and we know everything, then you should think about this picture. Because if you look at this, in big scheme of things, we are just a dot in the sky, right? And hopefully that feeling will ground you, and you all know that if you are an electrical engineer, grounding is very, very important. Okay, if you can go to the next slide. So here we have been, as I said, that we have been looking into different, trying to find out, is there planets outside our own solar system, and we have found about 4,000, they are called exoplanets, and many there all comes in many sizes and shapes. But thing is that that's what we are trying to do. We are trying to find out new planets, and we are trying to learn more, as much as possible about them. How they are formed, how is there an atmosphere, and then to find out, is there life in those. But you can see the majority of these planets are far, far away. Some of them are 40 light years away. And 40 light years, it doesn't sound that far, but if you think about it, if you are to go by current day technology, it will take 40 million years to reach there, which means that we won't be able to reach to those planets to find out. So we'll have to do everything sitting here, and which means that means that we'll have to build new instruments we'll have to actually develop new kind of technologies, and that's what we are trying to do here. So if you go to the next slide. So, but again, we have found, I said, the 4,000 planets. That's because we haven't really looked much. If you look at this Kepler mission that found most of these exoplanets, in our own galaxy, we have looked at only in a tiny area of our own galaxy. So there's so much more to explore, to find out more. And so that's what I wanted to show. If you go to the next one. So here I show that if how do you find out an exoplanet? This is one of the technique that we use, because what we are trying to do is, if you look at this star, this bright star, we look at that bright star, and somehow, when try to measure what is the total amount of light that is coming from the star, and when a planet goes in front of it, and then that amount of light, dims little bit, and from that we can actually say that, oh, there is a planet, and that's how we know about that planet, that we can say that, oh, there is a planet there. So if you go to the next slide, there's another method we can use called the Doppler method. So okay, it's not coming, so you can go to the next one. So we're also looking for water outside our solar system, trying to find out if there's water, because we believe that if there is kind of life that we know needs water. And that's why we are actually looking, and we are finding that there is huge amount of water out there in outer space. So that can be life if there is water. So if you go to the next slide. So another thing, we are trying to find out if Earth water may have come from comets. When our Earth was formed, we didn't have a lot of water available. So scientists believe that comets actually brought water to Earth. So, and that's very exciting, because how do you prove that? So we are actually building instruments to prove that theory, that actually comets brought water to Earth. If you go to the next one. So another place that we are looking for, we think that there could be life in our own solar system, is Enceladus. So Enceladus is a moon of Saturn, and we found recently that a lot of water is actually coming out from this planetary body, and then our aim is to actually send a spacecraft there and try to find out if water is coming out, what else is there? Is there any organic materials? Is there any life? So we are trying to look into that as well, and we are actually building some instrumentation for that. If you go to the next slide. Another place that life could exist, we believe, in our own solar system, in Europa. Europa is actually a moon of Jupiter. Like we have only one moon, but Jupiter has multiple moons, and we are finding that this Europa has a very thick ice shell outside, a very cold planet, and then planetary body, and then inside they have a liquid water ocean. And underneath that, we have a mantle that actually produces heat. So which means if there is a source of energy and there is water, is there life inside that water body in Europa? So we are actually currently working on a mission that will go to Europa and try to find out if there is life in the water ocean world of Europa. That will be very exciting to find out. That we don't know what form of life, what it will be. But if we can find something out there, that will be really exciting, and that's why we're building instruments to do that. If you go to the next one, I will actually try to finish up soon so that I can take questions. So we are actually building a lot of instruments to do that. Those are the science stuff, those are the big science questions we are trying to answer. That how do you build this kind of instruments? What we did recently is when we went to Mars, we actually built very small CubeSats. CubeSats are like shoebox size satellites. In there, they were used for communication, because what used to happen is when we are going to go to Mars and the spacecraft is going down to Mars, there is no direct link to Earth. So for about 7 minutes, we do not have any information what is going on in the spacecraft. Has it landed? Has it crashed? We have no idea. So to prevent that in future, what we did for inside spacecraft that we launched two, when it was going in, it actually launched, it released two very small satellites. Again, I said it's about 30 centimeter by 20 centimeter by 10 centimeter. It's very small, two of them, and it had one X-band transmission and it had a UHF transmission. What it was doing that we are communicating with the spacecraft with UHF and transmitting that signal back to Earth. And we knew that as the spacecraft is going down, what was going on with the spacecraft. So we did that. If you go to the next slide.
Sorry, there is a
okay, so go to the next one. Okay, something is, this always happens, but that's fine. So we're also, working on a lot of different kind of new techniques, a lot of antenna technology, a lot of detector technology. You can see here that we built something, this is very interesting because I call it, this antenna, I call fakir bed antenna. Fakir bed, you are all from, many of you are from India, so you know that fakir, the term fakir means saints. And saints used to sleep on bed of nails, some of them. So here, this antenna at 300 gigahertz is actually metal pins that are sticking out. And the length of these metal pins, if you look carefully, they're about 200 micron. We know the thickness of our hair is about 100 to 200 micron. So which means that this length of these pins are of the order of 1 hair to 2 hair thickness. So really tiny. So this is an incredible antenna, but very good antenna. So what we can do is actually put on the sidewall of the spacecraft itself, we can make some antennas and it can do a lot of good stuff. So that's what we are trying to do in future. So if you go to the next one. So we are also building some of the instruments. I call it, WhatsApp. The name of the instrument I'm building called WhatsApp because we are trying to find out what's up with water. And the key here is that we are building an instrument in a way, in a small shoebox size that can go to a comet and do a lot of measurements. And we have to do a lot of different innovations to make this happen because it will reduce power. An entire instrument has to work with 5 watts of power. Can you imagine 5 watts? Your light bulb is about 40 watts, 60 watts. So here we are talking about an entire instrument doing all kinds of really excellent stuff with 5 watts of power. So that takes a lot of innovation, and that's what we are actually doing in this. So we are building the instrument to go out there, go to comets, go to other planets, go to other planetary bodies, and try to send the signal back so that we can know more what's going on. Go to the next one. So here you can again some more pictures of those instruments that we are building. You can go to the next slide again, and I stop there. So this is some pictures of those instruments that we are building. That as I said, less than 5 watts of power. Total weight of this instrument is 2 kilograms. So I am building this instrument in our lab, and it will be flown on a mission to go to a comet. So I will actually stop here because I saw that there are a lot of questions coming up. So it makes more sense to spend the rest of the time to talk to you and answering questions. So you can go ahead and start dealing with some of these questions.
Yes,
I'll try to answer them to the best of my ability.
Sure, sir.
You can stop sharing the screen and so that you can see your face.
Yes. That was a nice presentation, sir, actually, and we are lagging with some time constraint also, as well as that video also it is not able to visualize, and it is a great to interact also. So I will ask a few questions from audience so that we can you can answer that also for that. Sir, one of the question is how to join interns at NASA for an aerospace engineering student.
Okay, so my first question is why don't you want to join ISRO? What is wrong with ISRO?
There are some.
Why you want to come to NASA?
Few constraints, NASA.
No.
Yes.
I don't. I was just kidding because of course you should actually try to join ISRO. Is a great organization as well. So to join NASA, there are multiple ways you can do. And one of the question when I was giving my talk, I saw that coming up. That does NASA take people from other places? NASA is open place. So we take students, we take people as engineers, scientists from all over the world. But one of the easiest way to come here is to come as a postdoctoral fellow. Because if you are already here in the US, then it becomes easier. Then we can interview you. We can actually find out what exactly you are doing and all stuff. So if you do your higher studies in the US and then apply for a postdoc, even from India, you can actually apply for a postdoctoral fellow. If you are interested, then you can go to a website called NPP, NASA Postdoctoral Program. So if you do a Google search of NASA NPP, then you will see that there are a lot of opportunities there, and you'll be able to apply for that. So yes, you can actually apply to NASA. You can find out, but to get a job directly from India, it's difficult, as I said, because it's easier to come in as a postdoctoral fellow, or if you're already in the United States, easier to apply and then come. It does not mean that you cannot get hired, but it's difficult to get a job directly at NASA from India.
Okay, sir. So another one question from Arjun Saibo. What is the future of propulsion in NASA? Fuel or propellant?
Yes. So, propulsion technology, that name of our lab is Jet Propulsion Laboratory. Of course, there is a huge group of people who are working on propulsion. So if you look at currently, most of the propulsion is chemical propulsion, right? We burn, chemical fuel, and that's how we do. But, a lot of other new technology, electric propulsion is a new big thing. So we are looking at only one of the challenges is that, yes, it's much more efficient. It can go much further. But to have the lift, more power, that thing, we are trying to figure it out, how we can make it more powerful so that it can get out of the gravity of our, Earth. So yes, there are a lot of new technologies going on. SEP, if you are interested, you can look around that. Electric propulsion is a new big thing, and people are really, doing a lot of research in that area.
Okay. Why another one question from Dark Matter, I don't know what was his name. Why ocean exploration isn't popularized as much as space exploration?
So that, you see, NASA looks at up in space, and it's not true that ocean exploration is not popular. There is an agency in the United States called NOAA. They actually look into the ocean. So it is equally, if you look at kind of the budget that is for NASA and NOAA and all, it is not true that ocean is ignored. So there is a lot of experiments, a lot of research going on to explore the ocean. But one thing is that ocean, if you look at ocean is only limited to our own planet. And when you're looking at space, you are not only looking at one particular planet, you are looking at thousands of billions of stars, galaxies, planets. So your landscape is much bigger.
Yes. Another one question from Jashwant. Will center of gravity affect on space station?
Center of gravity, I don't know what you mean by center of gravity. So gravity is there always, right? So, and that's how when you are doing the space station and you are doing all these calculations and all, of course, gravity plays such a big role. And if you go back to your high school, these physics of centripetal forces, and that all of these things will have to be taken into account.
Okay. So another one is from Sanket. What is the future of laser propulsion?
Laser propulsion. Okay. So a laser propulsion is light. So it is, you'll have to be careful because this is a laser propulsion, a light propulsion. How it happens that light or electromagnetic wave creates a little bit of that thrust, right? And that's how it can push. So it can help you to move through space, but to generate that kind of, as I was saying, the thrust. So I am not an expert in that area, but I think that people are looking into that. But it's debatable whether how much progress will be made in that area in near future.
Okay. So one of our student is having one doubt. I want to ask Arohi Garg to unmute and ask the question over. to you, sir.
Good evening, sir.
Yes, go ahead.
Sir, my question is I have been working on my research on black holes. So there are few questions I wanted to ask. So like the recent the black hole image that we have got in 2019, it was from EHT Telescope Organization.
Hmm.
So the question is
Hmm.
like they have been working for a decade and they have been sending X-rays to the black hole in M87 galaxy. So I wanted to ask that basically how that X-ray work and what are the difference between the simulation image and the EHT image that is known to the world.
So okay, so what I understood that you are talking about the recent. Some of you might not know, but recently the first image of a black hole was taken. The Event Horizon Telescope, and the consortium, they were able to actually map out. It's very, very difficult, as you all know, that to look at a black hole because it's black, you cannot really see. But what you see is that that the effect of the black hole around it, and that's what was captured. And that was not a single telescope. That Event Horizon was that multiple telescopes all across the globe, and they were able to do. And one of the things that excites me, because the frequency at which they were actually mapped is about 220 gigahertz, and that's fall in the terahertz range, and that's where I am. My work is in the terahertz area as well. So the SIS mixers, superconductor insulator superconductor mixers were used to actually build these detectors and this. So if you look at, again, as I was saying, that, to answer your question, that when you are looking at those images, you actually see that we are seeing the effects. So we are actually mapping just outside of this, the black hole, whatever the effect we can see of that. And that's how we can do, that of many different frequency bands, but it turns out that it's very sensitive in that 200 gigahertz region, and that's why we're able to map that.
So it's through the X-rays that we are sending from here to there.
No, 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 no. That is not. We actually did not send any X-rays. That is not. This is a passive imaging in the sense that whatever effect that is happening around that, black hole, and we are detecting those signals. We are not transmitting anything.
Okay, sir.
This is not a radar or a that kind of a system. It was a passive imaging system. That's what we were looking at and trying to detect the signal that is coming from there and not sending anything.
Okay, so sir, one last question. So, like we know that M87 is further than Andromeda galaxy, which is far more nearer to Milky Way than M87. Then why not we have seen the black hole of Andromeda than M87?
Yes, of course. You can ask this question, why we didn't see certain things, because there are a lot of different things are involved, in the sense, if you are looking at what is happening around that black hole, and what are the signals when you are looking at those black hole or not. So there is sometimes you see some effects from a large distance, and that those things are not really happening. We cannot really see even for at a nearer place. So that's the reason. It's not any other reason that why we didn't see in one and we saw in the other one.
Okay, sir. Thank you so much, sir.
Sir, another one question from Prakash Joshi. Recently, Pentagon or US Navy shared 2 videos of UFOs. What is your opinion on that?
I knew it's coming because whenever I give a talk, people ask me a couple of questions. One is about alien, one about UFOs, and another one about Area 51. So these questions are common. So to be honest with you, I don't know what to make of this, because UFOs are unidentified objects, right? And my opinion about most of this stuff is that if you look back on many other UFO sightings, that if you given enough time, and if you look into very carefully, people are able to explain what they are. So many of them, right? So some of them are still unknown. So I don't know what they are. Is there some kind of natural phenomena, or there's some aliens? I don't know. So if there are some alien, we'll be very excited. But there is no proof yet. So that's the only problem.
Okay, okay. So another one question is, as we are mainly focusing in finding new planets on our own galaxy, if yes means, then there is a possible of finding new planets in other galaxies. It is a question.
Yes,
Yes.
absolutely. One of the reason is that we are looking first. We are looking at our own galaxy. Is that signals that is coming? So what we are trying to do, as I said, how do you detect a new planet in from around a star? You are trying to measure the total amount of light that is coming from the star, and when the planet moves in front of the star, the amount of light goes down very tiny bit. So you need extremely sensitive detectors. It is extremely difficult to detect even from lights coming from our own galaxies. Think about looking at stars that are in out far off galaxies. So yes, with time, our technology will improve and you'll be able to do that. But currently, we are trying to look at first our own galaxies and see how many exoplanets we can find, and then when our technologies get better, we'll be able to go and look at other galaxies.
Okay. So another question from Ganesh. Uh, what are the design challenges of electronic systems to handle in unknown environment, like in other planets?
Yes, that's actually a good question. Is because when you are, when we send our instruments in outer space, we'll have to be very, very careful, right? So that one of the main thing that we'll have to look for is the radiation environment, because in outer space there is a lot of radiation. So we know something called TID, total ionizing dose. So what happens is that your detectors, your instruments, that in the process of the entire mission time, how much total ionization and the radiation it will encounter, and then what kind of effect it will have on your electronics. So that is very important. So we do that. We actually do radiation testing very, very much and try to figure out that how long it can survive. And there is another issue is called single event failure, because one can happen that there is a large energetic particle can come and hit your electronics, and it can actually make it go bad. So we'll have to have some cases, we'll have to have some backup system redundancy for SCUs, or sometimes you can actually restart the thing, your capability to restart your entire system so that you can come back on live. So yes, so these are big challenges. So we'll have to be very, very careful, and we have to take precaution to make sure that your system works in those environments.
Okay. So another one question is there a tomorrow there is a launch of X-37? It is scheduled. He's asking about that.
Yes.
Yes. So he's
Yes, it
asking
is.
about it. Yes.
Yeah.
What is your comment on X-37? X-37.
I didn't. I couldn't hear.
What would you like to comment on X-37?
No comments. Let's see how the launch goes.
Okay.
No comment. No comment really on
Yes.
that.
So next question is from Swami Charan. He asked, is it possible to manufacture spacecraft that can travel in speed of light?
So if you know about Einstein theory of relativity, then if you send something at the speed of light, then that there is a mass energy problem comes, right? So we have not we have never reached that stage where we have the technology to send something at the speed of light. No, so we are doing much less than the speed of light.
Okay. Another one question from Tarun Gandhi. What are your views on aerospike nozzles and its scope in future, and why we are not using them? Aerospike nozzles.
Aerospec? What?
Aerospike nozzles.
I didn't get. Huh?
Aerospike nozzles, sir.
Aerospike nozzle. I don't know what it means actually. I'm not able to understand that question.
Okay, sir. We will move on to the next question also. So when you have time, we can. Uh, uh, could you elaborate on JPL's inertial stellar compass?
Inertial?
Stellar compass. Inertial stellar compass.
Oh, okay.
compass.
So I don't know what that means, but if you are asking about the JPL's the facilities or JPL stuff that I can talk about, but I actually did not understand the actual question.
Okay. Actually, he's asking about an inertial compass, stellar compass. There is an inertial stellar compass.
Okay. Now I get it. Yes. So, JPL is building it. You'll have to build, when you are going out in space, right? So, question is, how do you know that, where you are, those kind of stuff. One of the things is that this compass things. Another thing we do is called star tracker, in the sense that, all the spacecraft will have a star tracker that looks at a particular star, and from Earth we know what the location of the star very well, and then with that respect you can do a triangulation and you know where you are. So these stellar compasses and the star trackers, these are the kind of technologies that is used to know about your location, because there is no GPS out in space.
Yes, sir. Yes. Another one from Prakash Joshi again. Can we use very large particle accelerator to accelerate nano satellites at lower speed?
Yes, but you'll have to see that, that how do you, what are the implemented, how you can implement those things, right? How do you really generate those accelerators, and then you do, do a propulsion. So some of this stuff that we think about are, maybe it makes sense on paper, but you'll have to look at the practicalities, right? How you actually implement. So if you can find a way to implement those, of course, then one can look into them.
Okay. So this might be the same favorite question as you said. One of the question is Apollo 11 is fake?
So it is not. Because there is a lot of conspiracy theories. You'll find for anything there are conspiracy theories. So on that thing, I always ask one question. Like, suppose you have a group of friends, let's say about 10 friends,
Yes.
and you want to, you want to hide something amongst 10 of you have done something, and you say, let's not tell anyone. For how long you think it will last before the news come out? Among only 10 people.
Yes.
So here in NASA for last 80 years, so 50 years, we had celebrated 50 years of NASA in 2008. So we have been here for a long time. 19 moon landing happened a long time ago, Apollo 11. So if it was fake, there would have been one person coming out and said that already. Have you heard anyone who have been working on this all these years? No, because it's true. I work in this organization. I see what it takes to actually do this kind of stuff. So it is it is not. It's real. So people like to, and also if you look at on YouTube, there is something called Mythbusters. There is a program called Mythbusters. So they actually look at the science aspect of these these conspiracy theories and try to tell that how wrong those conspiracy theories are. You should look into that.
Okay, that's great, sir. I also used to tell my students the same. So another one question is, can I study astrobiology or astronomy after graduation in aerospace engineering?
Of course, why not? You can study anything that you want to do. That one of the thing I tell people, that you should not restrict yourself, because you can study whatever you want to study. Astrobiology is a very important, because important area. Astrochemistry is important area. So if that is your passion, you should.
Okay. 1 minute, sir. Another one question from Ajit. What is the update of James Webb Space Telescope?
Yes, very good question. That you all know that the JWST has been getting postponed, and for many different reasons. There's a big project and huge challenging project. It's becoming very expensive as well. So right now the update is that a lot of instruments are already getting integrated on JWST, and we are ready more or less to launch in near future. That means within a year or two. So it is getting very close. Yes, I agree that it actually got delayed quite a lot, but we are almost there.
Okay. So another one question from Ajay Ramakrishnan. What are the major projects that NASA does for space debris?
space debris. Space debris is a big challenge that all of you know, because many of the countries, including NASA and others, we are launching a lot of spacecrafts up there, and then after some time, many of the spacecraft becomes inoperational, and then they create a lot of debris. And yes, one of the things that we are trying to do is trying to first you have to find out where the debris are, because then you will be able to avoid them if you can. And the second thing is that you'll have to have a not only NASA, you'll have to have an international effort to somehow come up with a way to clean up those things. How do you do that? Right. So one of the way to actually bring them down somehow, and so that they get, when they enter the atmosphere, gets destroyed. But there, many of them are very small particles, and so they are more dangerous, because the big ones you can see, at least small ones you cannot see, but they can be called really big damage.
Okay. From Praneeth, if we can manufacture so crucial equipment which work with 5 watt, then what restricts us to use such tech for manufacturing daily life equipment?
Oh yes, of course. If you can come up with something, daily life. Nowadays, you can see that a lot of things are very miniaturized, right?
Yes.
Really small, takes really small amount of power. So many of these technologies, and one of the good thing is that when we are building some instruments for space application, NASA application, it does not mean that it cannot be used some other area. So it has been proven that a lot of technologies you see today in day-to-day life actually came from space sector. So yes, so whatever improvement, whatever innovation we make in those areas can also be used in our daily life equipment.
Okay. So another one question from Ganesh. Can you share the most innovative moment of your research career? That groundbreaking finding in your
okay. So it's always difficult to answer this kind of question, because Eureka moment, Archimedes' Eureka moment does not happen that often, right? However, in real life, you actually make small progress, and then you sometimes you come up with completely new ideas that that is kind of path breaking, but that does not happen very often. So real life is always delta increment. So once in a while you see that there's something really big, because most of the problems, if it could have been solved, someone would have already solved, right? So if that was easy, so that really challenge, difficult. But yes, sometimes it happened that I actually have done some of the stuff that I feel very good about. There are always a couple of those things.
Okay. Do you believe that we can create environment of Earth on any of the planet for survival?
So you see, it is not about creating the environment, going there and creating environment, because you'll have to find a planet which has already the environment is similar to our own planet. That's what we are looking for, right? That's what we call habitable planet, habitable zone. And as I said at the beginning, that I believe that given all the stars and galaxies that we have and all the things we are finding, there will, I am very certain that there is at least one planet where, the things are so conducive for life. So we'll have to find that. And it's not easy, right? It's kind of finding the needle in a haystack. And it's so far away, so many of these. So that's the challenge.
Okay, so another one question is actually this has to be in it has to be asked for an ISRO scientist. So even I am asking to you, what is the approach of India to International Space Station?
So I don't really know. As I said, we'll have to ask someone from ISRO about it. I'm not as familiar about the plans about the ISS.
Okay. Okay, sir. So next question we can move to, why is NASA not sending people now again to moon? Actually, they have scheduled.
Yes, that we send people to moon, and then Of course, manned mission is always very exciting. But if you look around, that for a lot of scientific progress is done through these what we call the robotic missions, right? Majority of the mission that NASA has are robotic missions.
Yes.
So you'll have to see that NASA has limited amount of budget, right? So there are so many scientific questions to answer. So it is all about priorities, where you actually spend your resources. So again, yes, there is something coming up in the next few years, the Armistice project. That's where that we have to do the gateway to moon, and so it will be like kind of creating a ISS kind of environment around moon that will be the gateway. So you can go there and then from there go to moon. So yes, so new things are coming up. But again, as I said, it's all about managing your resources, where you want to invest.
One of the question from our student, for communication purpose, for like if spacecraft is revolving around Saturn or any other planet, for communication purpose, which type of transmission signal is used?
So yes, so basically most often we use X band, and nowadays we start also looking at K band. That is, X band is 10 gigahertz signal, and K band is about 30 gigahertz in that range. So we do is, when you go there, it's communication is one of the biggest challenges, because if you're going to outer planets like Saturn or beyond, so you need a big antenna, right, to send the signal back, because you need to have high signal to noise, and that's challenge. And most often for those places, there is no direct, we'll have to do DTH, direct to earth, right? We'll have this line of sight of earth, so that we can get the signal. If we are on the other side of the planet and we cannot see the earth, then we cannot transmit. So we always do plan in a way that we collect data, and then when our spacecraft is actually have direct view to earth, then we download all the data. So yes, that's communication. Space communication is not easy. It's one of the biggest challenge.
Okay, sir. Okay. And another one question: can we move close to sun, and which type of material we can manufacture?
There is a recent mission that was launched that is going close to sun. Going close to sun is one of the most challenges, because of the temperature and all those different kind of radiation and environment that you are in. So yes, close means how close? You cannot go to on sun, right? So it's about going as close as possible. And then the recent NASA mission that was launched is actually going as close to the sun as possible, and you'll have to make sure all the shielding and everything, so that you are not destroyed.
Yes. Uh, Another one is, what your opinion about space exploration and world politics?
Politics. I don't want to get into politics. But as scientists, as engineers, all of us, one thing we know all around the world, that collaboration makes things easier, right? So we'll have to collaborate, and it is for space missions. It is getting increasingly difficult and expensive to do by yourself. So it is very important that we all join hand and collaborate, and we push our politicians to make sure that there is no boundaries in terms of scientific world, so that we can all collaborate and work together.
Yes. Okay. So tell about Artemis program.
Yeah, just now I mentioned that Artemis is that gateway to moon. That program was supposed to be launched in 2022, maybe now pushed back to 2024, because yes, so there is a lot of work is going on, and also we are involving a lot of commercial companies as well to for the moon missions.
Sir, any updates on nuclear thermal rockets?
Nuclear thermal rocket, yes, there are some work going on, but nuclear rockets we'll have to be careful about. Always there is some concern about safety and other issues, because during launch or something, if there is a accident, what are the consequences of that? So there is a lot of challenges you'll have to be aware of.
Okay. Sir, there was a mysterious radio signal detected from space, right? So
Mm,
previously
yes,
there
people
was
are.
a yes.
Yes, I'm aware of that. People are actually so initially. So when you see some signal, you cannot really explain that it's mysterious, right? And then people are trying to look at it. What it happened? I think I read it somewhere that they're more or less figured it out that it was from some explosion from some stars or some area. So it's again, so you have to look more carefully and see what is exactly going on. What is the physics behind it? So most often there is some kind of physics, and of course it might happen that some aliens were sending some signals. We don't know, but it has not been proven that it was that kind. It's more of some event in a star or a galaxy. That's why some signals were
Yes.
detected.
Okay. Uh, Another one is there any possibility to hack communication system of rockets and missiles?
If you are trying to hack, of course, you should you should try so that they can fix their problem. I'm sure if you try enough, you'll be able to be successful. And what are you going to do by hacking in? That's my question.
Sir, another one question is the NASA are conducting many events, sir. Events, competitions.
Yes, absolutely. NASA has an outreach program, and there they always conduct a lot of different competitions and events for students
Yes.
from all over the world. It's not only just limited to
Sir, there was a concept going on like NASA is taking the concept of every individual and they are not showing that and they are doing the work like that.
So I think again that is one of those
Yes.
conspiracy theories.
Yes.
That is not true,
Mm.
because that my question to a lot of people, and I really strongly believe that again we should engage more ISRO as well. So in the sense that you say, okay, you want to do a competition, you want to come to NASA, why not do that in India? ISRO is such a great organization we have, so you should actually be proud of that and actually engage with them and try to do that. Yes, NASA is there, but ISRO is not lagging far behind. So we will have to be proud of that organization, and it's one of the greatest organizations in the world. So try to engage with them. Try to get involved in the competitions, and then your technology will stay in India.
Yes, sir. Uh, Sir, I think it's already time. It is 1 hour, and I think you have spent more time with us. And seriously, so till now there are 200 people online, 70 over here, and 100 people watching it the live also. So it is like a miracle thing happening. When we said that a scientist from NASA is going to interact with us, so our students as well as many people in the country from various institutions, they have registered into that, and I think yes. Thank you for your time, sir. Time, sir, to share your
I
knowledge.
want to thank you very much for taking your time. I know it's late in night in
Yes,
India,
yes, sir.
but you are all great. Questions were really good,
Yes, sir.
and all of you stay safe,
Yes.
because that what's going on around the world is not very easy. So I hope that we all come out on the other side of this COVID-19 situation much stronger. And again, thank you very much.
Thank you, sir. Thank you. Stay safe, sir. Thank you.
Okay, bye.
Bye, sir.
Bye.
Thank you all the participants for joining over here. Okay, you can collect your certificate or you will get your certificate on your Gmail. Okay, thank you so much.